So the next question we're going to do is majority element. What the problem going to teach us that it's work in linear time and we are using the constant space. So what we have, we've given an array of size n, and our task is to find out majority element. A majority element is defined as the element that appears more than n times divided by 2. So supposedly if we have input like this, you can directly see that 2 appears 4 times, and n by 2 is also 3. So if you see, the majority element always exists in the array that we are sure of. And if you see the brute force approach or brute force idea, the one simple approach could be like count the frequency of each element using the map, and tell that which is the majority element. But the problem is that it will take O of n time and O of n extra space. So what we have to do, the key idea is to pair cancellation. If an element is majority, like element is a majority, then its count is more than the other elements combined. So if we cancel one majority element with the one non-majority element, the majority element will still survive. So the idea leads us to a Boyers-Murray voting algorithm. So what we have maintained two variables, like candidate and a count. So candidate is a problem majority element, and like candidate is a, like what majority element should be. This tells us the candidate, like un until we are counting. So this is the majority element, and count is the vote count for that particular element. So we have got some rules to associate with this in the, if you see in the majority function, current count and candidate variable are 0, and if the count is 0, we have to pick the current element as a candidate, and if current element is equal to candidate, we have to increment the count, else we are decrementing the count and we're returning the candidate. So let's try run this particular solution. Suppose if we have the array like 2 2 1 1 1 1 and 2 2. So if you see, our current element is 2, candidate is 2, count is 1 at first iteration. So count was 0 and new candidate. Then our next element is 2, then our candidate becomes 2, count becomes 2, same as the candidate. Then we have 1 as the next in the next iteration, where candidate is 2 and count is 1. So different element, so that's a decrement to particular count. Then we also got 1 and candidate is 2, but our count becomes 0 because different element, that leads to decrement. Then we receive 2 and our candidate is 2 because the largest element. Then our count becomes 1, count is 0, but a new candidate enters, so it increments. Then again we receive uh, 2, so it will become the same, like it will increment. So similarly, if you see, uh, we uh, we are just like just having the one count here, then we are having two count here, then again we are decrementing it to 0. Then if we see 1, there is like we are just storing it 1 as the increment of particular element in that case. And if we are just incrementing the count, our candidate is changing to 1 here, and then again our candidate is changing to 2, and our count becomes 1 here and 2 here. So if you see, the output would be 2. Let's also dry run this particular solution and check. It will take like O of n time and O of 1 space complexity. So here we can see majority element is 2.